Welcome to another CO2 Monday with Trevor. I'm your host, Trevor Matthews. And over the last 5 weeks, I've had a lot of different guests talking about CO2. I've been involved with CO2 for many, many years, training people all over North America. But each week, I'm continuing to learn more and more from all the different experiences from the guests that they bring, which is really cool and very valuable. If you want to watch any of those recordings, I've been putting them on the Refrigeration Mentor YouTube channel. So go check that out there. Please shoot a comment below. I try to keep up to date on that, answer any questions, or reach out to the person or guest that was on the show and ask them the question as well, which is really cool to get the feedback from these experts. And today I have a really good friend of mine, Mike Harding from Gateway Mechanical. Me and Mike know each other for many, many years, and he's a true believer in training and development. He runs a crew of over 55 technicians, which is really huge. And he really wants to help all of them grow and succeed. And he's been involved in all their CO2 projects that's in his area and zone. And he's like the go-to guy at his company when they talk about CO2. So it's really exciting to have you on the show, Mike. How you doing, brother?
Good, man. Thanks for having me.
Awesome. Well, why don't we start off with you introducing yourself to the audience?
Yeah, so I'm Michael Harding. I'm the general foreman at Gateway Mechanical Services in the Northern Alberta branch. So I've been at the company for about 11 years, come May, and I specialize in supermarket refrigeration, data centers, and commercial HVAC. So most of my experiences come with supermarket refrigeration. So
Yeah,
yeah.
awesome. So how was that a transition? Because you've been a technician there and you grew through that company, and now you're a general foreman for the company. How was that transition and making your way through the company?
It's I'd say the toughest part is definitely going from like a tech to a foreman level. Just letting go. A certain part of the process is letting the guys make their own mistakes and kind of be there to support them and like on how to fix it. But it can be really hard. The guys are a little bit on the wrong path, but you got to let them kind of go through a job and get through it to kind of really understand how to do it better the next time. And sometimes when guys call me and they have this problem and your first instinct is just like, yeah, I'll just drop what I'm doing and come down and we'll do it together kind of thing. But just with such a large team, that's not realistic. And it can be hard, right? Like your whole like I will call like fully infield experience. You just want to, we're problem solvers, right? So you want to go there and help solve the problem and get things fixed. And so it can be tough letting go.
I love that though, because that's the big thing as you start to grow and you have more responsibility and a bigger team. And I heard the same thing from many other foremen and leaders at companies. It's because, like you said, we want to go and just help and fix the problem. You always want to help, but what you said by want them to learn, and that's how you got to learn. Sometime is by making those mistakes, and then be like, oh man, that's what I did last time. And then just continuing to grow that way. I love that. Mike, when was the first time you really got into or heard of like CO2 as a refrigerant or CO2 system?
So I first heard about it in school. We talked a little bit about it, but the first time I worked on it, servicing it was back in 2015. Yeah, so that was kind of the first time I got introduced to it.
And with
And
that,
then yeah, sorry, go ahead.
keep going.
Oh, I was gonna say yeah, I serviced that store by myself for about 4 years. I had a guy come with me every now and then, and then I had to pass it on because being a foreman and everything like that.
Yeah. So was that store a cascade system, a booster, secondary system? What type of CO2 system was it?
As a booster system,
It
just your
was.
typical transcritical or subcritical CO2. Yeah.
Awesome. So your very first one's a booster system because a lot of people that I've talked with, the first one was either a secondary or a cascade type of system. So that's really cool. A step up going from, standard HFC or synthetic refrigerant service to a CO2 system. When was the first time you really started? Because I know you do a lot of commissioning, you did a lot of startups. When was the first time you've done like an HFC startup? Do you remember that?
Yeah, HFC, I was racking my brain. Back in 2014, I did it. He's now my boss, but I did that first store with him. I was still an apprentice at the time. And then kind of right after that, it was quick succession for us at a couple Walmart locations. It just seems to come in waves. So I did like three in a year and a half, I think,
Wow.
back to back. And then and one of them was like a Save on Food store a few years later. But yeah, you definitely after the first one I mean, I had my foreman with me at the time, so we kind of went through it together. But the first one on your own, you definitely it's not going to be the smoothest ride, that's for sure.
Yeah, and that's fair, and that's a good way to learn. But it sounded like you had someone, to reach out with some questions, and getting shown with someone does definitely help. Which hopefully that helped your transition going into CO2. So you said you helped commission your first one in 2015, a CO2 booster system.
That was the first time I serviced it.
Okay.
Yeah, we actually built that store. It was like a few years prior, so I didn't get to start that one up. The first one I helped start up for CO2 was last year, and I just finished one like a few months ago. So
Oh,
we haven't
awesome.
had as many opportunities on the like to start up a CO2, and we've been winning a few more stores through maintenance and everything. So we've definitely have a lot more experience on servicing them.
Oh, awesome. No, that's fantastic. What is the biggest difference between servicing like an HFC store for you and servicing a CO2 store?
For servicing wise, I would say just mostly like respecting the pressures and really knowing the refrigerant for safety and handling. Really, when you break it down with CO2, once you get down the liquid line to the case side, it's all the same.
Okay.
You're just dealing
Okay.
with different pressures. It's just a different refrigerant kind of thing. And typically a little more electronic control, which actually is quite nice. Usually, you can graph a lot of data. You can get a lot of troubleshooting steps out of the way by just being at the computer and seeing a lot of real-time data, which obviously we all know, like having to bring out all those tools just to be at the case and to get that data, right? It takes a little more time. And just really understanding the system. I mean, to me, it almost seems a little normal. Like I've serviced a lot of different types of equipment, so you have to really respect. You have to really kind of look at it from the manufacturer and engineer's point of view. Like they designed this piece of equipment for a specific application and how they want it to run. So, when you swap over from refrigeration to HVAC, whatever, it's the same process. You need to understand what that piece of equipment is doing and the application. Does it line up, and make sure all your settings and parameters are lined in with that, right? Make it run as intended.
Yeah, and that's the big thing. There's so many different manufacturers out there of all the different equipment, and it's really important as like a technician to understand that equipment that you're working on. Can you tell me a little bit about that? The differences of have you worked on, I guess, different CO2 manufacturer equipment, or is it all the same manufacturer that you've
No,
been
so
working?
I've worked on the Hill Phoenix Advancer rack. That was the first one I ever did. So that was electric defrost, which is a little bit more forgiving on the defrost side of things. Worked on the Carnot rack. I would say I'm not too sure if it's the first or second generation, and the LMP rack. So they
Wow.
all have their quirks. Um, they all kind of have the basic prints. Between those three were the kind of the same booster style refrigeration. But all three of those racks had different defrost strategies. So
Mm-hmm.
again, the Advancer rack was electric defrost, just a typical, it'd be the same as a typical HFC store style. But the Carnot rack had what I would call same flow defrost, which was the first I've ever seen that way, where your liquid line was your hot gas supply, and then your return, it would just come down the suction line. And then it would just come through a check valve at the rack. And then the LMP is a traditional hot gas reverse system, like
Okay.
reverse pipes.
So that's
Yeah.
pretty cool. There's three different types of defrost you just explained right there.
Yeah.
The electric one's pretty straightforward, but let's
Yeah.
talk about the Carnot one that you see. I'm assuming you would have to have like bigger valves, or what would be involved in that if you're coming down with, hot gas. I'm assuming it's hot gas coming down the liquid line.
Yeah, it was. And yeah, basically what ended up happening is the installing contractor had to increase the expansion valve size immensely to get enough um, defrost capacity, like discharge capacity, in order to achieve the defrost. Now, that even with those large, really large valves, our defrost lengths for hot gas were around 40 to 60 minutes.
Wow.
Now, and that was because of coil square footage. Like a lot of the two stores that I've seen with that system in it, you'll have a system that has 4 to 6 cases on the circuit. So, and when you're not talking a walk-in, just sales 4 cases, that's a lot of square footage of ice
Yeah.
to
Yeah.
melt.
Yeah.
So, and then you add in, a lot of the line sizes are the same, right? You'll see a lot of 5/8 suction, 5/8 liquid. So, you have these smaller, pipe sizes, and you're trying to get that discharge gas going down, and then all of a sudden you start dividing that up to a lot of coil square footage, and your only hope is to either increase your pressure differential to get a little bit more flow out of it, and or some defrost termination strategy, and then time length. That's really all you got for parameters.
Oh, so that's really cool. That's what I like about different equipment manufacturers. Seeing different strategies just like this. There's different oil management strategies, different defrost strategies. What's really cool, which brings a whole different playing field when it's the first time you see it. What are some of the things you do when you see, say, a new piece of equipment like this? Like, what are some of your strategies? Like, this is the first time I'm seeing this equipment. What would you do, or what do you do when you come across a new piece of equipment?
Definitely, like if it's a new build, you got to have the rack manual and the
Mhm.
blueprints. I mean, I'm a big advocate for like self-learning and read, like really understand. You're going to be able to service any system way better when you fully understand everything about the system.
Mhm.
How is the sequence of operation? Am I falling within that? Is it piped properly? Like lots of times you'll find piping errors, and you're like, oh man, like do we have to fix this piping, or what can we do to like kind of navigate around this? So really, like the biggest thing, especially when you get into different rack manufacturers, a lot of things are going to end up being the same, but just fully understanding that sequence of operation to how that rack is supposed to be it'll shine a big light on how you need to set it up and service it.
Yeah, and that's so important. I talk about that a lot in a lot of different trainings I do. Is understand a sequence of operation, like you said, is so important because one sequence of operation from one manufacturer is probably maybe a little bit different, even though it's all the same principles of refrigeration, but it's probably a little bit different. So you really want to understand that. I love that. I love that. And that's what I do when I went into a new store or a new piece of equipment. You really want to understand that. And that last one, so you said the last one was System LMP, I believe, and they have
Yeah.
a reverse gas defrost. Is that correct?
Yeah, yeah, the LMP purity rack, it's a traditional hot gas, yeah, reverse flow.
Reverse flow.
Um, yeah, and you know what? It's pretty similar to a HFC style defrost. Kind of the big difference is you have an electronic valve feeding your discharge defrost header. So instead of having your traditional HFC rack where you have just a differential defrost regulating valve, and you kind of, it's typically an A8, large A8, and you set that 20-25 pound differential. Now you have an electronic valve looking at a transducer, and it is maintaining that pressure, that supply pressure you want. So, that's all part of startup, is tuning the PID on that and really getting it dialed in. So, that's kind of the biggest difference. You'll end up having, like, this system had a 60-pound differential across, so a little bit more flow. But then again, like at this store, a lot of coil square footage. So again, like just during commissioning, a lot of the other HFC stores I've had, you don't have to pay attention as much to defrost. You set that valve up, you set your defrost parameters on the E2 or whatever it is, and you test a few, and you're like, oh man, like we're defrosting well. But once you get into now, and this is kind of universal across CO2 and HFC, like if as soon as you start to add a ton of coil square footage or cases on a system, then you're going to start to see your termination temps start to come down, right? And you either need defrost termination solenoids, or you got to extend that time. It's very important to make sure that you're hitting those termination values. I mean, if you can't hit defrost termination at startup, not going to go so well during the humid summers.
Yeah, that totally makes sense. And um, with that, on those different defrost strategies, what are some of the challenges have you seen with maybe some of the techs or other startup guys going out there? Is this something that you talk with your teams or your groups when you're doing a startup on the defrost, for example? Is Do you guys spend some time on thinking that defrost strategy, or does that actually come from the manufacturer themselves?
uh I've seen it both ways. I've seen it where the manufacturer kind of provides basically what they want done for the defrost. Most of the time though, we have to set the schedule.
Hmm.
but I've seen it where they send us the parameters, so the time, the termination length, and the frequency, sorry, per day. But typically we have to set the schedule anyway. That's usually done by the startup guy. You got to set, and a lot of your classic stuff where you're putting all your frozen freezer doors in the middle of the night, right, and stuff.
Mhm.
Um, but yeah, like I definitely, whenever I train a guy on doing commissioning and startup, I show, like, I have kind of a process where I look at the map first, and
Mhm.
I have like a printable Excel sheet that's has the times on it and everything. And basically I show them, I'm like, okay, like, you want to look at all your cases. And it's really nice if you have the refrigeration schedule and you can actually see the loads, and
Mhm.
then you start to spread out your large loads. And part of having a really successful rack operate for its full length is balancing your defrost loads. So it's kind of those three things. Like that's where it's so huge to have the prints, the schedule. You can see then you kind of line up all your times and you play with it a little bit. You're going to have some overlap. It is what it is, but especially with a combination like low temp and medium temp rack, like it's a lot going on a typical store.
Yeah. So I do have a question here. So we talked about it over the last few weeks of what a transcritical system is. On the high side is your medium temp, higher pressures. Your discharge could be 1,000, 1,100, 1,200. Higher pressure, and then on your low temp side, you got 4 or 5 100 psi in your discharge. When you're doing a defrost, say reverse gas, which discharge gas are you using to do those defrosts?
I've seen it both ways.
Mm-hmm.
The Carnot rack uses the subcritical discharge.
Mm-hmm.
Um, the LMP purity rack actually they use the transcritical
Mm-hmm.
discharge. It's transition valve.
Okay.
And that's where you got to be really careful with commissioning too when you start it up, because that as soon as you go over from your transcritical side of the stainless steel typically down to the copper side, now that defrost header has a different relief valve
Mm-hmm.
in some sort of strategy, shape, or form, right? On this system, off the defrost header, there was a what they call a defrost relief valve that would just relieve excess pressure that the technician has to set to the flash tank. Now that last year we learned that valve is actually really important. Like um, that valve got lost by 15 pounds or so, and all of a sudden in the summertime we found out um, that valve, when we were in a defrost, we were trying to maintain 465 pounds, and that defrost relief valve is supposed to start burping into the flash tank around sorry, it's 565. Yeah, my bad. 565 supply pressure, and at 590, it's supposed to burp into the flash tank. And all of a sudden, it was burping in around 570, 575 pounds. So what that was doing, cause and effect, was bypassing discharge vapor into the flash tank and loading up the transcritical compressors. So all of a
Oh.
sudden, in the summer, I got called down there, and we and this was during the heat dome that everyone experienced. So we ran, because this was late at night, and I got the sprinklers going, and I went back there the next day, and what it was is, like, the system was fine except for this one valve. All of a sudden, it wasn't the store load going off and tripping the rack on high head. It was us bypassing discharge basically to your medium temp suction. So yeah.
So just to be clear, so that defrost header had a valve on it that goes to that flash tank receiver, and when the pressure in that line gets over whatever pressure, 590, it should open up and feed into there. But since it was opening up earlier, you were loading up the medium temp and running real hot. Okay. See,
Yeah,
that's
exactly.
really good to know, and that's specific to that manufacturer, because
Yes.
other manufacturers may not do it that way. That's why it's key to understand the different manufacturer equipment you're working with. So that's super cool to learn and to
Yeah,
understand.
and really that relief valve we're talking about that went into the flash tank, that's basically taking place instead of having a separate pressure relief to atmosphere. That's really,
Mhm.
it's just a design change. Instead of them having one more relief valve in the system, they're like, we're going to put this valve and you know bypass the pressure back. So yeah.
Yeah. That's really good. What are some of the challenge when you first started the service on CO2 stores, and because you're going from HFC and then now you're working on CO2 back in 2015, 2017, what were some of the challenges that you felt Because it probably was intimidating at first. Wow, I'm working on 1500 psi. What were some of the challenges that you thought as service and being, say, on call and stuff like that?
Um, yeah, I would definitely say not fully understanding the new design and really respecting the pressures and obviously respecting your triple point. Creating dry ice. So yeah, when you first go up to it, it's definitely intimidating. I mean, if you've worked on a lot of HFC stores, then the electrical side of it doesn't really intimidate you too much, like the panel size or anything like that. But definitely just the refrigerant part of it at first, the safety and handling, charging the system properly. That is definitely a little bit intimidating, and still working with the guys on that. But it's yeah. I mean, when you first go through it, it's part of something that you're going to work through. Like,
Yeah. And that's what I tell a lot of technicians, because I have a lot of technicians reaching out. Hey, Trevor, we got a few stores. I haven't been on call yet. You got any advice? Because it can be, nervous. Even taking on call when you're new. For me, even the first 4 or 5 years of on call, I was still pretty stressed out when taking the call, and I went to a new store that I'd never been at, and it's just something that you need to work at, and get there and see what the problem is. Do not overanalyze it before you even get there, and think about it. But with the CO2, I had calls from friends in the past, like, Trevor, I got to charge a CO2 system. What do I do? Well, sometimes hopefully you have someone at your company that you can call if it's the first time you've ever been on call and you have CO2 store, and say, Listen, there's no gas in the rack. How do I put it in?" And if you don't, do some research. Just like Mike said earlier, there's lots of information out there. There's rack manuals. It says it in, I've read a lot of CO2 transcritical system racks and subcritical manuals, and it tells you in there how to charge and the whole procedure step by step and how to charge. So take the time to read those. What do you feel now? Like, you have a big team and you have some CO2 service stores. You guys have meetings? You talk about CO2 when guys are first on call and they may get it. Like, what's your strategy with your team when they go to service CO2 stores?
so we have a internal CO2 kind of training. I guess I'll call it a program for lack of better term. I'm actually doing one tomorrow night. And basically from our dispatch level, we have a list of techs that can get those service calls first. And we kind of already have it broken down too, of like a list of grocery technicians and stuff like that. I do try to get a little bit, anyone that hasn't really taken, I'll say, the internal training for CO2, I still try to get them in those stores doing some case lighting calls, some where they're not really touching the refrigerant, or even just going to help one of the CO2 guys or one of our lead guys do the maintenance, just to get a little bit of exposure before getting full on calls. And then, I still get them to go and do there'll be a little like under counter cooler stuff. And then, you talk to them on the phone, hey, go up to the rack room, look at the piping, because at all of our CO2 stores, if it wasn't already there, I got them printed the piping schematics, because I found it's a massive help. You just, it's usually $60 from a printing place, right? You get it up on the wall, and now they can look at the rack and look at the piping schematic and be like, okay, kind of trace it out with their finger and start to really digest it and learn it. So we
I
try
re-
to really stage it in.
Yeah, I really love that. I think that's one of the most important thing you can do in supermarket systems for techs. And all my trainings, I get the technicians to do that. Follow the pipe. Where do they go? Because I did spend many years myself, and I did it in school, but then I was servicing equipment or installing equipment. And I didn't really spend the time to walk through, okay, here's the discharge line, here's where it goes, okay, it goes to the oil separator, and then step by step and find every single valve and the flow, because that's something you may do once or twice a year. But if you did it 4 or 5 times a year on all the different systems, because you just talked about 3 different CO2 systems
Yeah.
you work on, there's tons of HFC systems that are designed differently over the years, and things have changed. So as a technician, when you take the time to do that and follow the pipe and the flow, it just starts to click, I found. And over time, the more I did that, it just made more sense what's
Yeah.
happening in there. So let's talk about some of the things that you've seen or noticed after you went from the HFC system to a CO2 system? Like maybe some of the challenge, some of the things that you would like to have known before getting into that, and some of the differences, because there are some difference from HFC system to a CO2 systems. So, what are some of the things that when you first started out with CO2 that you would like to either known or share with the audience?
Uh, oh man, I mean, all of our systems have microthermo controlling them. Man, it would have been awesome to have a lot more knowledge on the in-depth programming for CO2 racks with the microthermal programming, because there is a lot of safeguards in microthermo.
Hmm.
Just and that, man, I mean, if you fully understanding that, and because it, for I'll give one example. In your case programming for microthermo, there's a parameter called what's called max operating pressure. So what that's for is if your system, let's say you have a power pump, shuts off, and you had a little bit of liquid out on the floor, obviously, in your evaporators and your liquid line, and your valves, if they're not the pulse width modulating valves, if they're the electronic expansion valves, they're stuck in that position, right? So
Mm.
they're open a little bit. It equalizes. All of a sudden, you've got your evaporators up to, let's say, 400 pounds, 380. And as soon as that control power comes back, it looks at the max operating pressure, and you set that. So normally what you'll do is you'll set that to, let's use a low temp case, for example, like you'll set it to like minus 15 Fahrenheit, or even minus 12 Fahrenheit kind of thing. So then at that corresponding pressure, if you are above that, so you're, let's say, around 5C for your SST, it overrides that valve shut. So it'll
Hmm.
essentially try to pump it down, and that's huge for restarting on a rack, because most of these rack manufacturers, they will have like a restart procedure,
Hmm.
and it'll set the EPR valve. Your, like, usually have electronic CDS valves it'll stage it up. And what the rack manufacturer is trying to do, it's trying to pump down the rack so that it gets vapor only coming back, because they know that after a power shutdown, you got liquid everywhere. You don't know where it is.
Yeah.
So you want to control that restart. So man, if I would have known, learning a little bit more of the in-depth programming, again, it's because, usually when you're getting called to these sites, it's when something happens, and it's usually
Yeah.
power bump or something like that. And then, you're trying to restart this thing and you're pumping down. You're like, what is happening?
Yeah.
Why are my valves not opening? Just fully understanding, oh no, let it bump a couple times. It's trying to pump down, and it's going to go through its restart timing.
Yeah.
And the other thing, really big thing I noticed different from going from HFC to CO2 is just really respecting the heat capacity. Like, holy man, I mean, I don't know how many times I've talked to guys, and I kind of walk them through, like, okay, you're going to do this case repair, you're pumping it down. And everyone calls me back and say, I can't believe how long it took to pump down that system. You go from a HFC system, you can pump it down usually 20, 25 minutes if you manipulate some things at the rack. All of a sudden you go to CO2, you can be like well over an hour to get the liquid out. And
Wow.
and you're just sitting there and because you want, and also the guys are being a little careful. They want to be safe and not have any liquid there.
Yeah.
um, but yeah, just really respecting like how good of a refrigerant it is. Like it's quite shocking how much you can get out of that, and then that kind of spirals down into like EEV sizing. Everything I've seen for CO2, your EEVs are oversized. Like even the smallest valve is typically oversized for its application.
Yeah. I really like what you talked about is understanding the programming, and that I think that's one of the biggest difference where it's the biggest changes for technicians, because most stores, HFC stores, you don't have case control. They're starting now. Over the last few years, more and more HFC stores had case controllers, but in general, they didn't. It's usually run off the rack controller. You get a solenoid or whatever. But now getting into more sophisticated controls and these case controllers, it's vital to understand how they work. I learned this the hard way when I did work at a manufacturer. Just learning those controls takes time, and there's many of them. There's not just one you got to learn. Sometimes there's three, four, or five different ones. They do the similar job, but the parameters could be different. They could be labeled different to do the same thing. And you're like, well, what does that really mean? And that was one that you said there. I've seen that happen before on some of the Alco controllers and Dixel controllers that I've worked on. Is where how come the valve is closed? Why is it closed? And it's flashing, and you don't know why it's flashing. And oh, it's maximum operating pressure. But you got to read those manuals, and sometimes they're thick and they can be intimidating, but take the time. If you read a little bit this week, a little bit next week, it's going to just grow that knowledge base. And then when you fix it, it's like, bam, eureka. It's like, oh man,
Yeah.
that's it. And you see all of a sudden the pressure start to level off. It's like your heart starts to slow down a bit, and you're like, oh man, got to write that one down.
Yeah, exactly. Usually the more traumatic the call, the more you remember it for years.
Yeah. Um, Did you have any issues when in starting up and commissioning systems? Because I've talked to a lot of technicians. They're like, Trevor, like I blew the charge off a couple times trying to figure out what was going on. There was valves opening and closing. I've had a technician tell me, it's like, Trevor, when I went into the store, I didn't know I wasn't supposed to shut off the medium temp side first. And we know you need to run the medium temp side to make sure the low temp side and loss of charge. Have you ever had any issues like that, or any seen that? Because I think that's one of the big things where guys are a little worried about blowing the charge off, and sometimes it happens.
Yeah, I haven't blown the charge off on a rack. I know our other branches, which is I think why I was a little bit more sensitive to it for when I was really dealing with it, and ever since it, because we did a few new builds in different regions before it got over to mine. So I heard all the stories, right? So I
Okay.
think I was like pretty sensitive to not blowing the relief valves. But yeah, definitely it can happen quick if you aren't fully understanding what's going on. I had issues with this one with floodback
Hmm.
because in this application that I just finished, the client was using the used cases, and it was a conversion from the Cardinal rack, and so we had really oversized EEVs, and I had pre-programmed a lot. Like some of it came from the rack manufacturer that they had gone in and done some programming. The microthermo tech that was there did some programming, but then a lot of it's like really fine tuning, right? Like especially on used stuff, you're tailoring the new build to this used stuff, and oh man, yeah, like that's kind of more so what I had issues with just really, and that's where I did some learning on that one. Like, okay, like next time, I'm going to do a huge deep dive into the case controls programming before I even turn on the rack. But yeah,
Yeah.
like I had, yeah, when I was trying to start up the transcritical side only, and it was like flood back like within seconds, and you're like, holy, like what?
Hmm.
I haven't even walked back the computer yet, and you're turning off compressors, right? And
Yeah.
yeah, yeah, a few issues. Yeah.
Yeah, I had Phil Woodrow on a few weeks ago, and he talked about um, the largest, like they're seeing the largest failures you've seen with CO2 is because of floodback, because of the way that CO2 mixes with oil, the way it carries oil, and you need to
Yeah.
have superheat. And it's no different with Copeland compressors or Durain or whatever CO2 compressors you're working with. When CO2 is traveling through the systems, you need to have and maintain a certain amount of superheat. It's not like the standard, like Copeland's standard for HFC is 20, which they'd like to see on their semi-hermetic, but with CO2, that's not the case. You can have upwards of 36 degrees superheat. You need anything lower than that oil is not being distributed, or it's not lubricating properly. And I've seen many compressor scrolls, semi-hermetics failed because of floodback. So that's something you need to watch out. And I really think what I've been noticing, more manufacturers are very cognizant of it, because I think at first they're like, okay, well, they're starting to learn, and we're still learning. Like the manufacturers are still learning. It's still new. Like in North America, I think I was told in like the late 90s it came into Quebec, and then in the early 2000s there were some systems, and then but in really last 10 years I believe that's when more and more systems start to get out there, and I think we've learned a lot in the last 10 years. So I see manufacturers, they're adding heat exchangers, they're running heat exchangers through the receiver or flash tank. So there's a bunch of different designs that I'm looking at, and it's important to understand that, because that's another part of the system. So all of a sudden you see heat exchanger right before the maybe the compressor, and you're like, well, what's this heat exchanger for? Oh, it looks like a desuperheater or a superheater. So it's another part of the system you need to understand and how to set it up, and do you have enough superheat? So I think that's interesting learning these new things.
Yeah, I've definitely noticed that as well with the over the years, first gen, second gen kind of thing. And yeah, like definitely the latest generations I've seen, they all have plate and frame heat exchangers for like either desuperheating or subcooling, some sort of strategy to control superheat to the compressors. Because it's obviously was a huge identified issue with CO2 because it just goes back to the heat capacity. It's just so often great.
Yeah. Well, and then a lot of technicians been programmed, oh, I got 20 degrees superheat or whatever, 30 degrees superheat, but that is not enough with CO2. So it's just a learning curve for a lot of people. And one thing I keep telling technicians, you got to look inside these compressors. You're not going to know because you're just going to continue to change them. You got to look inside them to figure out what caused that. So it's really good. What I really talk about too with technicians, and I'm sure you do this too, you really have to work with the OEMs. Like I've heard lots of techs, oh, this OEM doesn't know what they're doing, or this OEM's knowing what they're doing. When you're working with a new design, new systems like that, you work with them, bring back feedback. How's that relationship with the OEMs with you? How do you feel your relationships are bringing back information like that?
I've always found it's been really like quite good. Usually if you get a little bit of trouble, it's because you haven't got to the right person. Usually at the manufacturing level, if you're doing a new build or anything like that, if you get the right person, like technical rep, all of a sudden like they're there to help you and they're awesome and they know that equipment in and out, and then you can usually go through some of their equipment really quickly and they're kind of like, this is kind of what we've seen. You've got to really hone in on this area to make it right, kind of thing. So usually they've been quite good.
That's awesome. Yeah, because it's so I keep telling contractors, technicians, you got to work with the manufacturers. You got to talk with them. If they put in a valve the wrong way, it happens. Mistakes do happen. You don't have to be all negative about it and keep hard on them. They made a mistake. How do you fix it? Okay, let's get it fixed. What's next? Do we need to work together anymore? How do we develop? Because that's how you learn, right? Because some of
Yeah,
them are learning as well. At the end of the day, they're
yeah,
learning because this is a new technology, new controllers, new valves, high ambient strategies we talked about I think 4 weeks ago. I had Andre Patnode from Emerson on, and you got adiabatic cooling, you got mechanical cooling, you got parallel compression, you got ejectors, all these different things. So you really want to take the time to learn it and then work with that manufacturer on it. So call them up, find the right person, like you said. I think that's very important.
yeah.
So I have a few more questions here. Like, what kind of advice would you give to a technician that would want to, get involved with CO2 and start learning about it? Because there's a lot of technicians that know it's coming, but don't have any stores yet. Like, what kind of advice would you give those guys to get involved, start learning?
Yeah, definitely read some, like if you don't have any I guess exposure yet and you haven't had I guess access to service some of these systems, like there's tons of stuff online. Read some manufacturer manuals. Some of the rack manufacturers put out like actually like a training guide. I know Phoenix and LMP do that. They have literally like a training manual. It's only like 35 pages long, kind of thing,
Hmm.
and like that'll give you a ton of good information and a good starting point. And if you get the chance to go to a CO2 store by yourself, for the first time, and you think you're getting a little bit thrown into hot water or whatever, you know, what I tell all the guys, locate the emergency unit first. Just find where that override switch is. If all of a sudden, if you accidentally trip the rack off or whatever, if you know where that switch is, and even you can test it while the system's running, go and turn it on, make sure that switch works. Because at the end of the day, if you make a mistake or whatever and the rack shuts off, all I got to do is, okay, I got to make sure that I don't blow the pressure release. Okay, I just turn on that emergency unit. Then you can like take a breath. Okay, we're safe in the room, and what happened, right? Then you can start putting on your troubleshooting procedure and start going into it, right? But I
Okay, well,
find that thing, yeah.
why don't you explain that? Because there's a lot of people that don't know what the emergency system is. Why don't you explain that? And I don't think we've talked about it yet. So.
Oh yeah, no problem. So most CO2 rack manufacturers will have what we call an emergency unit. It's just a typical HFC condensing unit. A lot of times it's a Copeland condensing unit, and you have your liquid line going to your TX valve. and there's an internal coil on your flash tank, is what they usually call it in CO2. It's basically your receiver. Um, and there's an internal evaporator in there, and basically that emergency unit kicks on, and it's to maintain that flash tank pressure. So a lot of times it's, I don't know, around the 600-pound range for your relief kind of thing. And typical stores, they run around 450 psi liquid. So you set that emergency unit on a pressure control, just like an old school system, and just, hey, cuts in and cuts out to maintain pressure. A lot of times we'll set it to like a 500-pound cut in or 510, and then cut out at 450 kind of thing, to kind of keep it within the range. And that's all that system does. It's just to maintain the receiver pressure. Because if you've looked at any of the schematics, if your system shuts off, there's always a check valve coming back to either your suction or to your flash tank. So all your liquid, just like basic refrigeration, is going to migrate to your coldest point. We want that flash tank to be the coldest point. So that's what it's going to do. It's going to migrate it.
Yeah, no, and that's very nice. I know I talked to a lot of technicians, and there's not as many as they would like to see out there. I think it might be an option at a lot of stores, but that's exactly it's a key component if you have, especially if you're doing service, and understanding that where is that and how to turn that on, because if the power goes out into the building, you trip the rack off by accident. It's a way to make sure you don't blow all the charge right away. For that, on those pressure relief valves, are they self-closing? Are they electronic? How does that work when you start to lose gas? Would you lose all the charge at once if the pressure gets too high, or do they reseat themselves?
They usually reseat unless they get stuck, typically. And then, yeah, like LMP does a anti-relief setup where they have a solenoid and electronic CDS valve, or usually electronic, I guess that in that application would be called the hot gas valve. And that one is piped off, if I remember right, it's off the top of the flash tank. So, and then, most of these stores have a UPS battery backup, so you don't lose control power in a power failure. And, your strategy, and really it's an anti-relief. It is what it's called. It's to prevent your pressure relief from going off. So you set that valve up to the right, 10, 15 PSI below your pressure relief setting. And you want that valve to burp to maintain your pressure, as opposed to blowing your relief. Because obviously blowing a relief, at that higher pressure, it's loud. And I mean, if you're at a store downtown or whatever, you're going to scare a lot of people if your pressure relief goes.
Yeah, that's pretty cool. I think I've seen one or heard about a couple of those, which once again, it's changing that the design, growing, I guess, the knowledge base and testing stuff out there, and seeing these new technologies start up. The system that you have worked on, do they have are they all VFD, I'm assuming, or do they have any digital compressors on those ones, or what do they have on them as the lead compressors?
Yeah, all of them that I've worked on have had either VFD or digital. I've seen both.
Okay.
Most of the time, I've seen digital on the subcritical.
Okay.
Yeah.
Awesome. And so what is your strategy with your team? Because this is something that's very challenging, and I know I talk with a lot of businesses about this, that VFDs is not new to the industry, but we're seeing it more and more in all areas of refrigeration and HVAC. How do you talk with your guys about it? Because I've been hearing a lot more and more of a lot of stores have bypass on the lead compressor, and in CO2 you don't want to just bypass that first one. So how do you manage like the variable speed side, and how do you help your technicians with that?
Oh, I basically tell them, get familiar with it. It's not going anywhere.
Yeah, yeah, no, that's
But yeah,
fair.
usually uh, we can talk to the rack manufacturer, and most of the time they have their base parameters they want to see, especially for the VFDs. But more importantly, is understanding why you have it, why you have a minimum hertz. Most of the time it's for motor cooling, right? Like you need, you can't just put a compressor, let it go down to 10 hertz. Like you're going to have motor temperature issues, like, and you're going to wreck that compressor. Like all the manufacturers I've read about, they have minimums, like
Hmm.
usually it's 30% or 40% kind of thing, 50% sometimes. And so you got to really understand where those minimums are. And you know what? Like, it's funny. A lot of people get really frazzled with VFDs, and I don't really understand why. You know, when you really break it down, most of our HVAC applications, you have an enable for a VFD. It's like your start stop control. It basically your controller saying, "Hey, this drive can start," and then a speed signal, and then you have your all your related safeties. And so I think once you eventually break it down, it becomes less scary, and then people are, they start to really like them, and they're like, "Oh man, this thing is awesome! Like it really keeps my pressure flatlined, and the system runs better." So I think it's getting over that hurdle of shock and awe, and then really getting into understanding, like, "Oh man, this is great."
Yeah. And 100%, because the technicians that I've seen, especially over the last 4 or 5 years that I've talked about in the first time I had conversation, they're like, I don't really know about it. It's hard, kind of stay away from it. But those technicians that start to embrace the technology, I can continue to see like, oh man, this is awesome. Like, why haven't I worked on it earlier, or learned about it earlier? And this is what you should be starting to read about, these new technologies that are been here for many years, but they're going to just continue to skyrocket. VFDs, electronic valve controllers, controllers on a system. And I'm sure you're seeing this. You've been in the supermarket space for many, many years because you work on most of your system have controllers, a facility management controller, but even condensing units now is all controls, and you can see all these manufacturers because it makes them more efficient. Less components a lot of times. So as a technician, you need to start learning about the equipment you're working on, and VFD is one. And there's lots of different VFD manufacturers out there. So take the time to learn it. It is hard. It is hard at first, but after you start to learn it, like Mike said, you're going to see like, wow, I really like this technology.
Yeah. Yeah, every system I've worked on that's had a variable compressor, like I'll call it variable capacity, has run way better than fixed step. Yeah, I mean, I've done lots of the like digital compressor upgrades, and I mean, man, I was the one that did the original install for a pilot for one of our clients, and I mean, unbelievable. Like even when I was working with the guys at Emerson, they couldn't believe at how much we reduced the power factor. Like we went down from like 70% average on compressor capacity requirement down to 35
Wow.
just from adding a digital. And I mean, that's amazing for power savings for clients. So, and it just goes to show, like, you look at it from about just a power savings perspective, but then you think, man, like, look at my suction pressure. Now I'm able to raise that up, gain efficiency, and also, like, man, what is that doing for our condenser? All of a sudden, we're not having our condenser fans not ramming on and off all the time because the compressor turned on or whatever. Like, reduce compressor cycling, increase the compressor life. Yeah, overall system health goes up.
Yeah. And you definitely see that on CO2 systems. I've seen ones that have been started up correctly and ones that haven't been. And you have so much control on the CO2 systems, like, because there's pressure transducers and temperature probes everywhere, there's electronic valves, EC fan motors or variable speed fan motors, and then same on the compressors. You got variable speed and digital. So learning that startup and commissioning process, learning what each component does, it's a big job. We
Yeah.
talked about you got three different defrosts from three different manufacturers that they do the same thing, but they work three different ways. Understand each one of these processes, sequence of operation is going to make that system run so much better. So when you do run into an issue as well, you know what to kind of look for. Okay, well, we're tripping off on high head. My gas cooler is way too high. Look at the ambient outside. It's only 80 degrees outside, but we're banging off. What is the problem? Is my high pressure valve opening and closing properly? Let's go look at that. That's another thing. So the high pressure valve, the first time you've seen one of those, and the controller, I guess, I'm not sure who you work on because Dan Foss has high pressure valves and Sporlin, and there's a lot of manufacturers with them. What was your feel when you first got to see the high pressure valves?
You know, it was exciting. It was, it's something different, right? And you're like kind of like, oh man, like okay, and it is a little intimidating, right? Until you kind of get it started and stuff. But it was really cool. At the time when I first saw it, my foreman was with me. So it was cool. I got to ask him a lot of questions and stuff. So I didn't get to like struggle as long without, you know what I mean, without a little bit of guidance, because I was there to help him. So it was cool to have someone like right there, kind of, and I just probably annoyed him a little bit with asking so many questions.
Yeah, but that's fair. That's what you need to do. You need to ask questions. It doesn't matter if you're a technician, if
Yeah.
you're an engineer on here, or even if you're a manufacturer, you need to ask the questions because a lot of the manufacturers, they're using other manufacturers' equipment. So they gotta do a lot of research on those components as well. So it's so important to ask the question, ask the why. There's no stupid questions in refrigeration. And it just will help you grow quicker when you ask it, instead of waiting. Because I used to do that as a technician. I used to wait. Oh, can I get this? Can I figure it out? And then a lot of times I should have just asked that question a half an hour ago. I would have got
Yeah.
this much further ahead. Just ask the question. Spend a little bit of time on it. Have your processes, especially in CO2. I really think if anyone on here works with a company that have CO2 stores, you should sit down with your foreman, your service manager, and ask some questions. Because if you're going to be on call and you never worked on a CO2 store before, you should be prepared. You should prepare yourself. It's not up to the company all the time to hold your hand and prepare you for everything. We're refrigeration mechanics. We've got to take the time and the initiative ourselves when we know that we have equipment like that to work on and say, listen, I've not worked on this store before. What happens if I get a call? What are the things I should look for? And try to prepare yourself so you can take those calls. Like you said, Mike, you rely on a bunch of guys that'll go to those specific calls because the other guys aren't ready yet. Not mean they won't, but those guys, I bet, that show initiative and say, listen, Mike, I'd like to get out to one of those calls. What can I do? You know what I mean?
Yep.
Well, start investing in yourself, learning about the process, getting out to a store and looking around, looking at these legends, looking at the maps, the piping, and then show your manager, show your foreman that, listen, I can do this. Or even reach out to the manufacturers of that equipment. They want you to
Yep.
call and ask questions. Even though you don't work on the store, say, hey, listen, I know I have Advancer rack. Call up Advancer, ask the questions that are aligned. How do I find more information about your equipment? And they should point you to those manuals. You can find them on Google, though. Google's pretty good these days finding information. But so I love it. I love it. Um, Last question. Where do you see CO2 going in the supermarket space yourself?
I see it taking over, honestly. Um,
Me too.
I think like even in hotter climates now, like you kind of mentioned it, like they've come up with a lot of high tech solutions to kind of overcome that. It used to be kind of a cost effective analysis for energy savings on whether or not they do it, but I mean we're starting to see publicly companies commit to it, right? The other day I just read like Walmart and or it was Target. Target is committing to like changing a ton of their stores to CO2 to all natural refrigerants, and we're going to start to see that trend more and more. I know Walmart is committed to a lot of CO2 upgrades. Seems so be Safeway, and it's not only just like that you'll hear about it from through the contractors. Like this is public stuff. Like Target, I read about it and just online.
Yeah.
Like I think I saw it from LinkedIn. Like they're advertising that this is the way they're going. Um, and I get it. That's what I personally feel too. I think that CO2 is going to mostly take over for supermarket. I just think that it's such a superior refrigerant. Like when you talk about the base properties, and yeah, so I think it's here to stay. And I think everyone, yeah, you got to get on board for sure. And you know what? It's exciting stuff to learn, and it's different, and it's nice. And not having to pull out the recovery unit all the time is pretty nice too.
I love that. I love that. I'm sure at some point they'll have a recovery unit for it, but we'll see. We'll see what happens. It's real cool and hear your perspective on CO2 because it's nice to have an opportunity to talk with someone who's been out there in the field and has done it and who now have a bunch of technicians working on this equipment. It's something that you don't need to be afraid of. And that's what I continue to tell technicians. Don't have to be afraid of it. You need to understand it. It's just like when you get into supermarket for the first time, working on HFC equipment for the first time. It's no different. Or working on even a package unit or a residential unit. The first time, it's intimidating. It can be a little bit scary, but when you continue to invest in yourself and learn about it, it's going to get easier and easier. Any final thoughts for the guests and CO2 technicians out there?
Just basically, there's always someone to call. In this industry, you got to really take solace in that someone has seen it before. So, at some point, somewhere, shape or form in your community, local community, like there's someone you can reach out to, or even the manufacturer. Like, you're ever struggling, it's definitely a trade that you gotta embrace calling people and stuff, and embrace learning, and just embrace that, there's not one person that knows it all. Everyone's learning.
Yeah, 100%. I'm learning right now. I learned a ton today, and I want to thank you so much. How could people get a hold of you or Gateway if they want to learn more about you guys?
Yeah, you can just reach out to us on our website and everything like that. I'm on LinkedIn too, so yeah, you can shoot
Yeah,
me a message, whatever.
yeah, definitely connect with Mike on LinkedIn. I want to thank you so much, Mike. Does anybody have any questions? If they want to throw it in the chat, we'll stay on for a couple more minutes. We got 5 more minutes. But once again, I really appreciate your time today, Mike, and really appreciate your questions and comments and answers.
Yeah, man.
So you recently worked on a CO2 store, didn't you? You were mentioning to me.
Yeah, we just wrapped it up late February, early March.
And how'd that one go?
Pretty good. That was the one with like a little bit of flood back issues and stuff.
Mm-hmm.
So yeah, we like sent some stuff in to like for the client and consultants to review and stuff. But yeah, like that one I learned so much on EEV sizing for CO2. Because I was forced into it because of the use valves and everything like that. And I really got the impression that there's still a lot of learning in the industry. Like for instance, if you're just talking the Sporlan EEVs, like I know a lot of the new stores and new cases, they're kind of doing a blend between the EEV and like the pulse width modulating valve.
Mm-hmm. Yeah.
But when you look at some of Sporlan's literature for the EEVs, like your smallest valve, like they make the SCRA and the AA. Those two valves basically do. If you look at your tonnage charts, that basically does everything in the supermarket. But even it's amazing. Like it basically everything. You can maybe go up to a SCRB, which is like one size up for like a large walk-in box. I was just pulling up one of the charts to give you an example. So for instance, the SCRA at your, like in a medium temp application of like -5C is roughly, I don't know, like 15 or 20 Fahrenheit kind of thing. The lowest tonnage is 2.6 tons. The lowest.
Yeah.
Like we're talking about valves that, in region freezers, half-ton valves, 1/3 ton valve, right? Like, and so you think about that, like, and if you've done a lot of HFC supermarket refrigeration, you're kind of like, well, wait a minute, like I was able to, take a Danfoss valve with a cartridge and really dial it into, that 0.4 tons kind of thing or whatever. You're like, what? The smallest valve is 2.6 tons? Like that's huge,
Yeah.
So yeah, like once you fully, I got my head fully wrapped around that, and I actually had to reach out to Sporlan because they don't even have all this information out there yet. Like they haven't made it yet. Like they have it internally. I had to get them. Like I was able to find low temperature charts pretty easily, but medium temp application, I actually had to get that from Sporlan.
Yeah.
They actually had to send that to me, and because I was looking at some of the valves I had, and one of the like the most common service call we have at our CO2 stores is EEV valve failure.
Oh wow.
And if you have worked on those EEVs before, that or CDS valves, it's all the same technology as the stepper motor, right? So if you really look at the breakdown of the valve, you have basically a machine thread screw down to your seat. And with CO2, because you have such a high heat capacity, and those valves being the tonnage, like your port size is quite large. So where's your valve position? Well, it's right at the bottom, right? You're right at like that 2%, 3%. So just like any mechanical thing with some fine threads, what happens if you do it over and over and over and over on the same few threads? Well, it gets stripped and stuck. So that's usually most common thing. We have to replace that valve because those threads strip and the valve can't close.
Wow. Yeah, and I've
Yeah.
I've heard of that as well from other people. But that's once again, it's new. It's still new. So this is the stuff why you want to work with the manufacturer. You want to contact them and help them out grow as well because they want to make superior product. Doesn't matter all the big manufacturers out there that I've worked with and talked to, they want to have the best product. So we giving this feedback, talking to them is only going to make their products better, which is awesome.
Exactly.
Mike, I want to thank you so much for hanging out with us for an hour, and I'll see the rest of you at another CO2 Monday with Trevor. Have a great afternoon. Bye now.
Bye, everybody.